Hello all. In this video, I will do one math from Poisson distribution, and that will be enough for the Poisson distribution because it is a very small part. Uh, I will first read the question and remind you the formula, and then we will solve the math. Yeah. So the math says records indicate that on average 3.2 breakdowns per day occur on an urban highway during the morning rush hour. Assume that the distribution is Poisson. Okay, so 3.2 breakdowns per day on average happen. Let me remind you the formula and write down what's given. So probability of X for Poisson distribution was e to the power minus lambda to the power x divided by x factorial. Here e is the logarithm base, x is the number of success or whatever that you want to calculate, lambda is the average number of that event. So the question again says the average number is 3.2. So basically lambda is 3.2. Okay, so let's write it down. What's given? Lambda is given 3.2. Okay. Now part A of this question says, find the probability that on any given day there will be fewer than 2 breakdowns on this highway during the morning rush hour. So it says you have to find the probability fewer than 2. Okay, so what does fewer than 2 means? Fewer than 2 means probability x less than 2, right? So probability x less than 2 means you have probability x equals to 0 and probability x equals to 1. Fewer than 2 means you have 0 and 1. Okay, so I will just do it once and rest of the time you will solve it. So let's solve it for probability x equals to 0. Basically, we will plug in the values in this formula. E is the logarithm base, which is already in the calculator, to the power minus lambda. That means to the power minus 3.2. Lambda is 3.2 again. 3.2 to the power x, so 3.2 to the power 0 divided by 0 factorial. You have to do this directly in your calculator. So type e to the power minus 3.2 3 times 3.2 to the power 0, then divided by 0 factorial. Do it all together. So you will get the value 0.04076. All right, then you also have to do it for probability x equals to 1. For 1, again, e to the power minus 3.2, 3.2 to the power 1 divided by 1 factorial. If you do this in the calculator, you will get 0.13 0.3044. And if you add these two, you will get the final result. So if you add these two, the final result will be 0.1712. So this is the Poisson distribution. The formula for Poisson distribution is easy. You just have to plug in the values. But the only thing you need to understand, even for binomial or for Poisson distribution, is the condition. You have to understand what fewer than 2 is and what you have to find out, basically. All right, I will go back to the question again and see part B. Find the probability that on any given day there will be more than 4 breakdowns on this highway. Okay, more than 4 breakdowns. So how do you write the condition for more than 4 breakdowns? We'll do it here. So let me explain this first. When you say more than 4, that means that would be x greater than 4. You understand that there is no cutoff point. If x is greater than 4, it will start from 5. There is no equal sign here. More than 4, just more than 4 means it will start from 5, but there is no cutoff point, so it will go till infinity. So it will start from 5 and it will be till infinity, which is not possible to calculate. So how can we calculate this? I have showed it in previous maths. So before 5, I have the values of 0, 1, 2, 3, 4. So if I find out these probabilities and subtract that from total probability, which is 1, then I find the rest of it, or this part. So I find 5 till infinity. So how can I solve this math? I will find out 1 minus probability x less than or equal to 4. So let me explain this again. You can write it down as x less than 5 or less than or equal to 4, which eventually means the same. So when I say probability x greater than 4, that means it starts from 5 till infinity, which is impossible to calculate. The rest of them, or that the values that are not in the condition, start from 4, 3, 2, 1, 0. So if I get this probability and subtract it from 1, then I get this part, or this condition. So I can write it as probability x less than or equal to 4. So when I write less than or equal to 4, that means that is 4 and less values. So 4, 3, 2, 1, 0. I have to find out these probabilities and subtract it from 1 to get the final result. So it will be 1 minus probability x equals to 0 plus probability x equals to 1 plus probability x equals to 2 plus 3 oops, sorry. plus 4. Probability x equals to 4. I hope you understand my handwriting, so I just wrote what is less than or equal to 4, 0, 1, 2, 3, 4. These are the probabilities that we have to find out, and finally we will subtract it from 1. Notice that in the previous math, or in part A, I have already found 0 and 1, so you have to calculate it for 2, 3, 4. Please do calculate. I will not calculate it for you so that you practice it. The way I have done it for 0, 1, the same way you will do it for 3, 4, 5. The only difference will be the change will be in x. X will be 3, x will be 4, again x will be x will be 2, x will be 3, x will be 4. So you have to find it out for 0, 1, 2, 3, 4. And after finding this 0, 1, 2, 3, 4, the result will be 0.78061. So this result will be 1 minus 0.78061, and if you subtract that from 1, the result is 0.2194. So the result is 0.2194. Again, the formula is easy. You just have to plug in the values, but the main part of the math is understanding the condition. It says more than 4. More than 4 means starting from 5 till infinity, which is not possible to calculate. So you have to consider the previous values, and the previous values are 43210, which you can write it as less than or equal to 4. And after getting those values, you subtract it from 1. Then you actually get the probability that is equal to 5 till infinity. Okay, so this is it from Poisson distribution. You just have to solve this math to understand how the maths for Poisson distribution works.